Okay, now we're going to do some more practice of related rates word problems. So I'll link the video that I did before in which I explained kind of what related rates relate to. So we're not going to do that here, but go look at that if you're still confused as to what exactly is going on. We're going to work on this problem, which is that we have a spherical ball, and the radius of the spherical ball is increasing at a rate of 2 centimeters per minute. And we want to know what the rate of the surface area of the ball is increasing at when the radius is 8 centimeters. So what do we have? What is given? Right? Let's write down what is given. Well, what is given is, first of all, that we're dealing with a spherical ball and the area of a sphere. Actually, let me write that. Let me write that differently. Let me write A to the S for sphere, is 4 pi r squared. Okay, so that's the first thing that we know. You may have had to look that up. Everyone doesn't know all these by heart. I sure don't. And the second thing that we know is that the ball is increasing at a rate of 2 centimeters per minute. Well, what does that mean? How would we write that if we were differentiating? Because that's what we're doing here, right? We're going to be implicitly differentiating this formula right here. Well, we know that the change of the radius over the change in time of the ball is 2 centimeters per minute. So that is dr by dt, change in radius over change in time. That's a d. And that is 2 centimeters per minute. Well, we're going to use that before the problem is up. We're definitely going to be using that. So that's good to know. Okay. Well, what are we looking for, right? What are we finding? We're going to try to find dA by dt. So the change in the area over the change in time. Well, we know the area, and the change of the area is going to be the differentiation of this formula. And we're going to need to use the chain rule there. So let's bound this and let's get started on the actual math. Okay, let's start down here. So dA s by dt is going to be d by dt of 4 pi r squared. Okay? R and t are not the same variable. A variable mismatch means chain rule. So what do we do? Well, 4 pi is a constant. We can pull that out, right? So this actually is 4 pi times d by dt of r squared. And now we can really see our mismatch. Well, that's fine. Chain rule's not so hard at this point, right? So let's go over to the right side because I'm running out of space. We have dA by dt is 4 pi times, okay, now we're going to apply the chain rule. We're going to differentiate r squared with respect to r, and we're going to multiply it by the inner function r, the change in r with respect to time. So that's dr by dt. Well, we know what this is, right? This is 2 centimeters per minute. 2 centimeters per minute. And we know what this is because we have the same variable here. We can just use the very most rudimentary of our differentiation rules, the power rule, and it's 2r. So we know that actually the change in the area over the change in time is going to be 4 pi times 2r times 2 centimeters per minute. Well, how do we want to write our solution? We want to do it in the correct notation, and the correct notation is actually going to be that we write down dA by dt Well, because we know what the radius is too, don't we? We know that the radius. Actually, I'm sorry. Do we know what the radius is? Yes, we know. It's 8 centimeters. I didn't actually write that down, but we do. We know that r is supposed to equal 8 centimeters But that's only now. So I'm going to write that in the correct notation. I'm going to write that in the correct notation right here. I thought there was something like that. Okay. And the reason that I did that is because I really like writing it down at the end. And so we're differentiating this when r is 8 centimeters. And the reason we do this is because it's just for this case, right? It's just for the case that r equals 8 centimeters. Well, r could equal, r could equal 9 centimeters in the next problem. So this is how we write that. And what it equals is 4 pi times 2 times 8 centimeters times 2 centimeters per minute. And now these brackets aren't really necessary anymore because we're multiplying everything, but it's good to keep things straight and know what's happening. So what does that equal? Well, what does that equal? We don't really want to get rid of the pi, because then all of a sudden you end up with ugly numbers. So let's just multiply what's inside and multiply that by 4. So we're going to end up with 4 pi times 32 centimeters squared per minute, okay? And our final solution, we're going to multiply that by 4 and leave the pi out, and we're going to end up with, 4 times 32 is 128, so we're going to end up with 128 pi centimeters squared per minute. That is the change in the area over the change in time when the radius is 8 centimeters of a spherical ball.